The third verified interstellar visitor is hurtling into our solar system at a blistering 130,000 miles per hour. On the surface, 3I/Atlas ought to resemble nothing more than an enormous comet. Yet its trajectory sweeps by Mars, Earth, Venus, and Jupiter in a strikingly precise, swift progression. Such a path carries odds slimmer than 0.005% if left to random chance. The object's vast dimensions, bizarre speed-up, and eerie alignment with four planets have leading experts murmuring, could 3I/Atlas actually be a nuclear-fueled scout vehicle probing our defenses? Should it prove artificial, the implications skyrocket. Our species' inaugural encounter with extraterrestrials, and how we react, might hinge on forthcoming revelations. But what clues could ultimately reveal the true nature at play? By July 2025, the evidence starts piling up. Designated as 3II/Atlas, this entity slices through the solar system at 130,000 miles per hour, a pace swift enough to span the Atlantic in under 2 minutes. Its documented width, approaching 20 kilometers, marks it as the biggest such outsider detected to date. To put that in perspective, it's roughly Manhattan's span, barreling along faster than any comet or asteroid we've tracked. Teams handling astrometry at the Ryugyong Observatory and TESS pore over initial sightings, recording positions to millisecond accuracy. From scores of photographs, they piece together an orbit showing a hyperbolic arc, untethered and locked on a single-pass route across the system. Still, the model falls short of flawless. Lingering discrepancies in the observations point to slight shifts from the predicted pull of gravity. Researchers argue over what it means. Are these mere glitches from observational inaccuracies, or early signs of an influence surpassing gravitational forces? Typical comet theories anticipate minor non-gravitational boosts, like streams of vapor erupting from sun-warmed ice and veering the core astray. However, for 3I/Atlas, the surrounding haze appears dim and strangely placed, with scant signs of traditional gas release. The light curve defies norms even more. Its luminosity stays constant, without the usual pulses or dimming tied to spinning or outburst-driven bursts. Given its scale and velocity, natural mechanisms ought to imprint clear traces: heat backlash, explosive ejections, radiation warming. But instead, the readings display almost engineered uniformity. Computations of escape speed back up the orbital clues. Without any braking force, 3I/Atlas won't get snared by the sun's grasp. The surplus hyperbolic speed it retains post-solar influence ranks as one of the steepest for any natural body. To certain observers, the lack of an obvious natural propellant sparks speculation. Might a concealed propulsion system lurk under the haze? This quest for clarity drives stargazers to scrutinize further, picking apart every irregularity in the wanderer's path, this city-sized intruder from beyond. Come August 2025, the mapped trajectory of 3I/Atlas carves a route piercing 4 planetary zones in under half a year. First Mars, next Earth, followed by Venus, and finally Jupiter. Every rendezvous falls within mere fractions of an astronomical unit. Far from a casual solar skim, it's a multi-world jaunt. The approaches stay near enough for scopes to snag in-depth spectral data, but far sufficient to dodge orbital entrapment or disastrous collisions. Simulations at the Ryugyong Observatory and from separate groups mimic the itinerary using thousands of digital replicas. Even factoring in detection flaws and potential vapor emissions, the pattern endures across most viable orbital variants. This visitor's course navigates razor-thin gaps, grazing Mars and Earth's paths, dipping within Venus's loop, before catapulting outbound to Jupiter. The setup isn't merely uncommon, it's exceptional even among rarities. Simulations of random interstellar ejections and entrapments forecast that fewer than 1 in 10,000 such drifters would casually hit this string of tight planetary passes. The AVU group releases a compelling stat: under 0.005% likelihood for any haphazard arrival to replicate this 4-planet sequence. The idea spreads via Telegram channels, preprint platforms, and meeting corridors. Skeptics counter with detection preferences, finds favor items hugging the ecliptic plane, where surveys focus most. Yet, post-adjustment for these tilts, the probabilities stay dauntingly slim. This orbital ballet ignites fresh inquiries. Does it suggest a scouting mission? Optimizing viewpoints with reduced hazards. Every world provides a distinct solar system vista, and the order, Mars first, Earth after, Venus next, Jupiter last, prioritizes viewing without tarrying in binding gravity. The route implies design, or at minimum a regularity that defies easy natural accounting. Among planet experts, discussion shifts from odd physics to potential intent. The follow-up puzzle: if it's a survey run, what's the next phase post-scanning? A vibe: the Harvard astrophysicist who previously thrust Oumuamua into alien artifact discussions wades into the 3I/Atlas fray. Accompanied by a fresh alert: the trajectory of this interstellar intruder as it navigates past Mars, Earth, Venus, and Jupiter isn't merely a statistical anomaly. According to Loeb, it hints at intentional scouting. He highlights the improbability, under 1 in 20,000, per his estimates, for any arbitrary spacefarer to execute such a sequence. This statistic spreads through academic drafts and evening broadcasts, stoking theories that 3I/Atlas isn't aimlessly drifting but actively observing. The route mirrors a concept from speculative fiction, the dark forest idea. Here, all advanced societies pose risks, compelling them to conceal themselves lest they face annihilation. Should 3I/Atlas represent a reconnaissance craft, the reasoning suggests it would survey our star system remotely, grazing worlds without venturing near enough for capture or confrontation. These close passes optimize reconnaissance while curtailing vulnerability and steering clear of gravity traps that could hinder or ensnare an unwary traveler. Every encounter proves short-lived, every viewing opportunity transient, as though the entity gathers intelligence swiftly and departs before detection allows intervention. Loeb's team links it to Oumuamua's enigmatic 2017 passage, proposing that if the prior visitors served as a precursor, 3I/Atlas might constitute a sequel, a bigger, more purposeful endeavor. The interval of 8 years aligns with a structured timeline. Skeptics argue the notion over-relies on serendipity and overlooks biases in data selection. Nonetheless, the discussion intensifies. Could this be a benign exploration, a probe of our surveillance capabilities, or a graver peril? The uncertainty persists as stargazers assess the perils of visibility in a cosmos where discretion might trump inquiry. Dr. Rachel Stevenson, a planetary expert at JPL, examines the emissions from 3I/Atlas and detects a recognizable composition. Its tenuous, peculiarly leading envelope includes water, carbon dioxide, and minor organic compounds, typical markers of a comet birthed in the frigid voids beyond stars. Hubble observations show a hazy glow toward the sun, absent any distinct outbursts or shiny metallic hints. Surface brightness data aligns with reflective icy particles, not fabricated materials. For Stevenson and the majority of her peers, the most straightforward interpretation holds: a comet, though an uncommon and substantial drifter, not an artificial craft. Spectral analyses monitor the carbon dioxide to water proportion at 8:1, one of the richest documented. This indicates formation distant from stellar heat, preserving carbon dioxide, frost over eons. Isotope profiles, while preliminary, align with the broad range observed in local comets and Borisov, the previous interstellar interloper. The envelope's luminosity, gauged across various bands, fluctuates with proximity to the sun, devoid of any rhythmic internal activity. Fresh observations erode the bolder assertions, anchoring arguments in empirical science. Still, the matter of reaction endures. Engineers at Project Lyra model pursuits. Reaching 3I/Atlas requires a delta V of no less than 60 kilometers per second, far exceeding today's propulsion tech. Concepts like light sails, drawn from breakthrough starshot, could potentially connect, but demand minuscule loads and extensive advanced coordination. ESA's Comet Chaser lingers at L2, primed for leisurely targets, yet falls short against this velocity. Currently, observation hinges on optics, not spacecraft. Advisors on policy review the Outer Space Treaty stipulations: no solo transmissions, no atomic weapons in orbit. Every step demands global oversight. SETI and UN panels deliberate broadcasting or reticence, balancing contact hazards against passivity's price. Guidelines emphasize vigilance, collaboration, readiness. As 3I/Atlas hurdles onward, global reactions hinge less on its essence than on our approach to the enigmatic. Its 20 kilometers diameter, 130,000 miles per hour velocity, and swift planetary sequence, traversing Mars, Earth, Venus, and Jupiter in mere months, rank it among the scarcest intruders in solar system annals. Even with confirmed non-gravitational boosts and a trajectory odds of under 0.005% randomly, scans from JWST and terrestrial scopes reveal a nebulous halo and elevated sheen matching established cometary traits. Unresolved elements persist. The root of 3I/Atlas's odd propulsion and the prospect of future kin. With limited viewing time, initiatives such as ESA's Comet Hunter and Project Lyra detail contingency plans for swift engagement, be it cosmic relic or construct. 3I/Atlas urges humankind to confront the inscrutable through rigorous inquiry, foresight, and transparent sharing.